Hello, everyone. Welcome to today's lesson. In the rapidly advancing field of automation, robotic workstations play a more and more significant role. These workstations not only need to perform production tasks efficiently and accurately but also must have good maintainability and scalability. To achieve this goal, we need to make full use of various tools and functions during the design and construction process. Today, we will explore the RoboGuide simulation software together, understanding how it helps us build a basic robotic workstation and what practical aspects its functional modules offer. Next, we will focus on the composition of the virtual workstation and the introduction of the model. Through this lesson, I hope you can accurately describe the components of the virtual workstation in the RoboGuide simulation software and understand the importance of these elements in building a basic robotic workstation. First, let's understand the composition of a virtual workstation together. The premise of offline programming and simulation is to establish a virtual workstation in the software that mimics the real worksite, as shown in the figure. This scene includes industrial robots, welding robots, handling robots, etc., tools, welding guns, grippers, spraying tools, etc., workpieces, workbenches, and other peripheral equipment, among which robots, tools, workbenches, and workpieces are indispensable elements that make up the workstation. Next, we will introduce the types and functions of models in RoboGuide. 1. EOAT model. EOAT is a tool model belonging to the tooling module and serves as the robot's end effector. Common tool models include weld torches, welding pliers, grippers, spray guns, etc. As shown in the figure, it is a welding gun tool from the software's built-in model library. The tool module is located on the robot's 6-axis flange and moves with the robot. Different tools can simulate different effects during simulation runs. For example, when simulating a welding program, the welding gun tool can produce sparks at its tip. When simulating a handling program, the gripper tool mimics the real opening and closing actions and picks up the target. 2. Fixture model. The fixture model belongs to the fixture module and serves as a carrier for the workpiece in the simulation workstation, a work fixture. As shown in the figure, it is a workbench model with a tray where workpieces can be placed. The fixture model is one of the important carriers of the workpiece model, providing a platform for the realization of simulation functions such as processing and handling of workpieces. 3. Machine model. The machine model belongs to the machine module, which is a movable module, and like the robot model, it can achieve autonomous movement. As shown in the figure, it is a positioner model from the software's built-in model library. The machine model is used on movable mechanical devices, including linear motion devices such as conveyor belts, pneumatic cylinders, and walking axes, as well as rotary motion devices such as turntables and positioners. Throughout the entire scene, besides the robot, all other models that need to achieve autonomous movement do so by establishing a machine module. In addition, the machine model is also one of the important carriers of the workpiece model, providing a platform for the realization of simulation functions such as processing and handling of workpieces. 4. Obstacle model. The obstacle model belongs to the obstacle module, as shown in the figure. It is generally used for peripheral equipment models and decorative models, including welding equipment, electronic equipment, fences, and so on. Its own model attributes do not have practical significance for simulation, but its main function is to ensure that the layout of the virtual environment is consistent with that of the real site, allowing operators to consider more comprehensive factors when programming. For example, when writing offline programs, the robot's path should bypass these objects to avoid collisions. 5. Part model. The part model belongs to the part module and plays the role of the workpiece and the simulation workstation. It can be used for processing and handling simulations and simulates real effects. As shown in the figure, it is a chassis model from the software's built-in model library. In addition to demonstrating simulation animations, the most important function of the part model is its model-to-program conversion capability. RoboGuide software can acquire the numerical model information of the part model and convert it into program trajectory information for rapid programming and complex trajectory programming. These are the types of models and the RoboGuide simulation software. Through this lesson, we have gained a deep understanding of the components and their significance in the virtual workstation within the RoboGuide simulation software, and we have become proficient in the functions and applications of various models. This knowledge and these skills will provide strong support for us to build efficient and stable robotic basic workstations subsequently. I hope you can internalize this learned content and externalize it in practice, continuously improving your professional skills. Thank you all for your active participation and attentive listening. See you next lesson.